What are the different components of Hadoop framework? MapReduce. MapReduce is the data processing layer of Hadoop. It's a software framework for easily writing applications that process vast amount of structured and unstructured data stored in HDFS. HDFS, Hadoop Distributed File System, which is mainly used for storage. It also works as master-slave pattern. Namenode acts as a master node which stores metadata of Datanode, and Datanode acts as a slave node which actually stores the data. Yarn, yet another resource negotiator, used mainly for resource allocation. Yarn is processing framework in Hadoop. Comparison between Hadoop and RDBMS. Volume of data. For the lower volume of data, such as few GBs, RDBMS can fulfill the requirement. For large volume of data processing, RDBMS becomes very slow, then Hadoop can suffice the requirement. Latency. RDBMS can give a very quick response when the data size is ideal for its processing power. Hadoop is efficient for batch processing of the data. Hence, the results are available only after large amount of data has been processed. Therefore, Hadoop is not ideal platform to use when immediate results are expected. Throughput. It refers the amount of data processed in a period of time, and Hadoop's throughput is higher than RDBMS. What are the difference between Namenode and Datanode in Hadoop? Namenode. It's a daemon that runs on master. It is responsible for dividing tasks among the data nodes. Namenode should be deployed on a reliable hardware. It stores metadata information about the data stored in data nodes. Whenever a data node goes down, the name node has to send the balancer command to store the blocks into some other data nodes. Data node. It is a daemon that runs on slave. It is responsible to store actual data. Data node can be deployed on a commodity hardware. Data nodes need to be continuously send the heartbeat to the name node. How much metadata will be created on a name node for 1 GB of data file? Name node metadata stores the location of data nodes. When a file placed into HDFS, it splits into blocks. Let's say for example, file size is 1 GB and our block size is 128 MB. Then it will be divided into 7 and 1 blocks. The name node keeps track of all these 8 blocks. Corresponding to a block, 150 bytes of metadata is created. We have 8 blocks with replication factor of 3 by default. Hence, 3600 bytes of metadata will be created for 1 GB of data file. What should be the block size to get the maximum performance? Block size is a continuous location on hard drive where data is getting stored. HDFS stores each file as a block and distribute it across the Hadoop cluster. To get maximum throughput for a large file using very large block, 128 MB or 256 MB is best. For, for small file, smaller block size is better. What is the problem with small file in Hadoop? A file which is less than the block size 64 MB or 128 MB is referred as small file. Below issues will occur with small files. Many times the client needs to interact with master. Each node will have too much files chunks resulting in too much pressure on the network connection. Metadata will be too big since master has to track all the files information. Why HDFS performs replication though it's a data redundancy? HDFS performs replication to prevent fault tolerant and improves the data reliability. Actual data stored into HDFS, so we cannot afford data loss in any of the below circumstances. Node is down, node lost the network connectivity, node is physically damaged, node has made intentionally unavailable for horizontal scaling. Why HDFS stores data using commodity hardware despite higher chance of failure? HDFS is a fault tolerant by replicating the data blocks and distributing it amongst different data nodes across the cluster. It has replicas of blocks in different data nodes, so it is economical to store the data on commodity hardware. What is the replication factor in Hadoop? Default replication factor is 3. For example, if in a 3x replication cluster, we plan a maintenance activity on one node out of these 3 nodes, suddenly one node stops working. In that case, we will still have 2 other nodes, which makes Hadoop as a fault tolerant system. 3x replication factor is also solves rack awareness scenario. We can change the replication factor in HDFS site.xml. How Namenode manages data node failure in Hadoop. HDFS has master-slave architecture in which master is Namenode and slave is Datanode. HDFS has single Namenode manages file system namespace, metadata, and multiple data nodes which contains the actual data. Each data node sends heartbeat usually in every 2 minutes and data blocks reports to Namenode. Receipt of a heartbeat means data node is working properly. If Namenode doesn't receive the heartbeat, it assumes the data node is either dead or not functioning. Then all the data blocks transfer to other data nodes, which blocks are replicated initially.